7.3, 7.4, reteaching. First question, write each one as a logarithmic form. So you want to look at your base. Remember, your base is the number that has the exponent. That's the same base as the little number in the log. So when you're writing this, these numbers always get flipped to the flopped. So this would be log base 5 of 0.008 is equal to -3. So when you're looking at this, the 5 is the base, and whatever the number is with the 5 in the original, that's what it's equal to in the opposite. So if we look at this other one, my base here again is 5. So I have base 5, so that means log base 5. The 4 is with the 5 here, so that means it's going to be equal to 4. The base gets split up when you change from exponential to log. So it'll be log base 5 of 625 is equal to 4. The next set of problems are going from log to exponential. So again, first you look for your base. So here's my base. So my base here is 2, but now I'm going to rewrite my problem. It's equal to x, so now it's exponential of x. Now it's equal to 32. Again, you flip-flop the equals. Here's my base. My base is 4, so it'd be 4. Change it to exponential, whatever it's equal to, it becomes your exponent. Equals 64. Write as one single log expression. So you have to know your properties of logs here. So one thing I'm going to do is I'm going to just write log base 2 because I can combine these so they have the same base. Now if I see subtraction, I know I'm going to have division. Subtraction, when I write it as one single logarithm, is division. So there's nothing in front, so anything that's subtracted, whatever in the log, that's what goes on bottom of the fraction. So this right here is a positive number because there's a positive out in front. So this will be my answer. Again, when you see subtraction, that is division when you write your one single log. And for this one, there's two ways you could do this. First thing I'm going to do is take care of this multiplying right out here. Because when I'm multiplying, the property with writing one single means that it can come back inside of the exponent or inside the log and becomes an exponent. So I can rewrite these all with whatever I'm multiplying is now inside with my exponent. And just like the other one, I'm going to write log just one time. I see subtraction here, so I know I'm going to have division. This is positive, so that goes on top. This is negative, so this goes on bottom. This is positive, so that also goes on top. The only thing that would be dividing if it's negative. So this would be my one single log. Zoom out, that's the only two I have. And whoa! Write an expanded form. I don't want any exponents. So when I'm looking at this, there's two ways you could do this. First, I'm going to get rid of my multiplying here. I'm going to separate each of these and my division here. So I have a log base 3 of 9. Now these two are being multiplied on top, so since they're on top, that becomes a plus. Log base 3 of x to the 5th. Now my z is on bottom, so it's subtraction. So log base 3 of z to the 5th. I don't want any exponents. And you should see if you can simplify this nicely. If you can simplify this nicely, then you should plug in your calculator, or you can think 3 raised to which power is 9. So you put that in your calculator, you should get 2 out. This exponent to write as, or expand it, would come out to be multiplying. This would be 5 log base 3 of x. This exponent comes out in front to be multiplying. Subtract 5 log base 3 of z. Bing, bata, boom. Next one, please. Where is it? Where is it? Same type of thing. So first I'm going to rewrite my log. So this a to the 8th is on top, so that's going to be a positive. B to the 5th, that's on bottom. That means it's being divided, so it's going to have subtraction in front of it. C is also on bottom, so I have to also have subtraction with that one. Don't want any exponents, so anything that has an exponent should become a multiplying out in front of the log. So 8 log of A minus 5 log of B, that's a B, minus log of C. Bing, bada, boom. Here we go. Here we go. Here we go. Here we go again. Looking at this one, I see multiplying. So I have log base 4 of 16 plus log base 4 of x and negative 2. Two things here. You want to see if you can simplify this nicely. You can simplify this nicely. This becomes, if I put in my calculator, becomes a 2. This has to come out in front, the whole negative. So this actually changes to subtraction. And that makes sense because log base 4 of x, a negative exponent means that it would be on the bottom of the fraction. That's actually division there. And the last one, properties of exponent, or logs. All of these are multiplying, so that means when I write it as one single log, I'm going to put it as adding. Now this is not going to give me a nice number, so I'm going to leave it as log to 8th. This, though, I do not want any exponents. Log 8 plus 5 log x plus log w. And the last ones, these you just have to learn how to plug them into your calculator. Now if you don't have the log button, it's always, that means I would have a log base 10 over log base 2. Remember, if it does not have an actual base written, it is always base 10, just like that. So if you put that in your calculator, that would be roughly, should put a little squiggly, estimated 3.32. That's a point. So again, my last one, and then looking at this, if you don't have that fancy button on your calculator, you take log of the big number, divide by log of your base. That gives you the change of base formula. It would be the same answer as if you typed it in with, that looks just like this with that special button. 1.23. About. There you have it. Review of 7.3, 7.4, logs to exponents, exponents to logs, and properties of logs.